seems like it's erratic. That's why this one is not so consistent, unlike the others, which are pretty consistent. Even though there's a few exceptions with ionization energy, it's generally consistent. Okay, we've already talked about all this stuff. Do you want me to wait for you to copy all that down? We feel okay? All right. This is about as far as I got last hour. We had started atomic radius, and I was showing, okay, measuring atomic radius is not easy. Because you think, oh, all you have to do is figure out what the distance is from the nucleus out to the outer electron. Well, the problem is that where the electrons really are, we can't really tell. You can't take an instrument and analyze because they're moving so fast. There's not a clear line where the outer edge of the atom is. We don't have any devices, any instruments at all, even in 2018, that tell us where exactly that last electron is, how far it is. So what scientists will do is they'll try to solidify a compound, not a compound, an element, because we're dealing with all the same atoms. So they'll solidify an element. They need to make it solid so that the particles are as close to one another as they'll be. And it would be the solid phase. As a gas, you know, they're already, you'd have a lot of empty space between them. You want no empty space between them if possible. And they'll shine X radiation at the two atoms, or however many atoms there are, and the nucleus on both atoms will absorb the X-ray, and it'll leave a shadow on the X-ray film. So they can tell where the two nuclei are, and they can extrapolate back based on the angle that they shot the X-ray at into the sample, how far the two nuclei are from each other. So they can measure the distance from that nucleus to that nucleus, and they just cut that in half. And that would be, okay, well, half the distance from there to there would be that, and so they estimate that as the atomic radius. So it's not easy to measure any of these things. It's just a very high-tech thing. Daniel?
How do they find the atomic radius for like elements that only exist for like a couple seconds?
I don't know if they do. I don't know if they can. This periodic table, some of them have atomic radius on them, that one doesn't. Yeah, but I mean, you could grab your phone and, like number 111. The systematic name of that is unununium. So maybe you can take your phone and type in to Google atomic radius of unununium and see what it says.
Is that really the name?
Yeah.
No, he's just trolling.
No, I'm not trolling. I know that it's got an RG up there where I think there has been some agreement on what they should name it. I think they have been named since then. When did I say this one was made? 2007. So I believe that those elements all have been named. But on this periodic table, it still doesn't.
IUN?
1, 2, 3. Yeah, there's 3 UNs in a row and then EON. Those are the systematic names that they come up with before they actually. Normally, these days, they'll name new elements after scientists.
Like curious.
Yes, yeah. There's Einsteinium is up there, Mendelevium. Yep. Nobelium is one of them.
The only letter that's
Wait, is that
Yeah,
the
some
symbol?
Marvel fan named thorium.
Is that the symbol? The symbol's UUU?
It used to be, yes. It's now RG, RF, RG. Yeah.
Yeah, it's also known as Roentgen.
Oh, Roentgenium. Yeah, I was thinking. Yeah, Roentgen was a guy that did some work with.
They have its density. No, they don't.
Okay, what about atomic radius?
They
Now?
don't. They just have.
So yeah, I don't think they can come
It's
up
just
with
PM.
those.
It doesn't even say any number.
Okay. Yeah, it's probably so unstable that they can't isolate and find out how big the atoms are. Okay, so anyway, as you saw earlier this hour, I did show this. I'm just going to stop here. I love this graphic because it really helps us to get a visual on what exactly is happening. Rather than just showing you a graph with values, we can see, okay, we're talking about size of atoms. These are relative sizes, and this works pretty well for us. So we'll pick this up tomorrow, and I promise it'll go much faster tomorrow. Thanks for staying awake. I'm really appreciative of you staying with me. Everybody.
Yeah, it has an atomic radius.
They do have an atomic radius.
138 PM. That's because its half-life is 10 minutes.
Okay. Who's elected to come and
Oh,
finish us?
yeah,
You got this?
come back.